Welcome to the last class in the Agentic Workflow part. So today it's going to be slightly dry compared to what we saw in the previous classes. No math, no interesting things. It's just going to be dry protocols. So try to bear with me for some time. And also protocols are like highly interconnected. So I'll try to teach it in a certain flow. Of course, you will have a lot of questions. So as and when you feel like something is really confusing, please let me know. Then I will either say that I will cover some parts of it later or I'll go through it. If I'm not going to cover that later, then I'll try to solve the issues right there. Okay. All right. So far we've been looking at how do we build AI agents and what all components it should have. But we have very conveniently stayed away from what libraries would you use or what framework would you use and things like that, right? So the way we describe React or self-refine or reflection or memgpt, so far if you have not worked with AI agents, so far your opinion would have been that maybe I'll have to write the entire code from scratch and make it work for my use case, right? But there are a lot of these agentic platforms or frameworks that exist out there that lets you build agents as quickly as possible, right? Some agents are very tied to certain proprietary LLMs. Some frameworks are very tied to certain proprietary LLMs. They are hard-coded. Some are slightly more flexible, but the learning curve might be slightly higher. Some are meant for developers who are well versed in Python. Some are meant for people who have no computer science background, but rather they just want to drag and drop components and plug things together, right? So there are like all flavors of frameworks that exist out there. And of course, if you have to create an agent on any of these frameworks, you have to understand what that framework does, and they have their own way of defining things and collaborating, right? So now let's see in this setup. This is the situation now, right? We have so many different frameworks, and when people work with so many different frameworks, what happens, right? So this is the same situation where sort of the World Wide Web was in the initial phase. It was not worldwide. Even though they were connected, you probably would have to know the exact URL to the finest, to like every character in the URL, type it in your browser and then try to access it, right? And it was not easy back then. Like one website would not connect to another website and get you some other information and stuff like that. That website existed in a silo, like it doesn't know about anything else that exists, and you would go there, right? And slowly people started developing protocols like HTTPS, HTTP, DNS, search engines came into picture, and catalog of websites came into picture where you can discover websites by searching through the catalog. And then search engines came and things got a lot more easier. Then these protocols became a lot more capable, and then things became even more convenient where people started to expose some services within their website and other websites can access. And now you see that the power of the internet, right? It is such complex beast where they interact with themselves in a very which we cannot comprehend at the moment, right? So people predict similar things to happen with the agentic space as well. Like currently people are working in silos. Like you have your own framework such as LangGraph or LangFlow or Crew AI or AutoGen, or you can develop your agents using OpenAI's Agent Kit, right? So there are so many different frameworks. People are developing their own agent, they're hosting it in their own server, and unless you know how exactly to access that agent, you won't be able to access the agent, right? So you probably have to install an app to access that agent, or you might need to know the exact URL to access the agent and things like that. So this is the current situation in agents as well. So this is a time where you might need protocols, right? And for agents to work, it's not just between two agents. Even agents access tools. Agents access a lot of artifacts. Like if you're working on a RAG system, you need access to the corpora, right? And the other big issue is that let's say that you figured out how to use chat GPT well for, let's say, summarizing like policies related to maybe some company or something, right? So then you would have you if you have to create a QA system on top of that, you might have prompt engineered like so well that it works well for this type of documents, right? Now, if you have solved this problem, most likely a lot of people would also be having this problem, right? Then how can you expose those? If that's a very useful artifact that can be reused, right? But it's not exposed anywhere, and it's up to you whether you keep it in GitHub repo within your agentic code base or you make it in public. There is no standard protocol again for things like that, right? So this issue of how do we define artifacts, how do we define communication between agents and artifacts, agents and tools, agents and resources, like these are not well defined, right? And it's all ad hoc. So now like I'm in the mid of 2024, people started to think along these lines, and then so some of these protocols started to come up, right? So how many of you here are familiar with MCP, or have you heard of MCP? Maybe I should start with that. Like almost everybody would have heard MCP, right? How many of you know what exactly MCP is without any confusion? Right? So in today's class, we will cover MCP a lot, okay, and briefly touch upon some other protocols as well and see what they are, okay? So like I said, starting from 2024, people have come up with a lot of protocols, right? So there are two main classes. One is the inter-agent communication, right? Which is like if you build an agent, how would you expose this agent so that everybody else can also leverage the agent, right? And what type of communication should happen between two agents so that they can form a handshake and then leverage each other's advantages, right? So those are all inter-agent protocols, and as you see here, almost all of them are 2025 and going forward, right? So they are at a very early stage, right? So if you see, there are 4 different development stages. Concept is people just thought about it. Maybe we need a protocol for this, and I think like these are the components in the protocol, and so it's more in the paper. Nobody has actually implemented it. It's just a proposal, right? And the second type of stage is drafting, where people are convinced that this protocol is worth exploring, and now they've started to develop it. They've started to code up the protocol and make sure that it's made available to everybody so that they can adopt the common protocol. And landing is where you've developed one version end to end. You figured out all the concepts, all the workflows, all the sequence of operations that has to happen. You've clearly defined the protocol. Now somebody has started to use it. Now you may face issues, and it is not very well adopted. Like some set of people, like for example, A2A is an agent-to-agent protocol developed by Google. Now apart from Google, nobody else is using it. Google has like made sure some of its collaborators are also on board, and it is trying to figure out how they can use agent-to-agent protocol within their community. Now, after when they are in the landing stage, they'll probably collect information about what works, what doesn't work, and they'll try to make it better. So there may be some changes to the protocol going forward. And factual standard is like a lot of people have tried, and then it has sort of stabilized. There's hardly going to be any changes. Maybe there may be some add-ons to improve further, but the protocol is well fixed and the adoption is good. Right? Now people outside the community that believe that this protocol is good also started to see there are benefits from this protocol, right? So if you see here, only MCP is at that stage, right? So people have found that MCP is actually helpful, and it has made their job of building AI agents easier. But in all the other cases, it's still at a very early stage. So this is like the developmental stages of the protocol. And like I said, I said there are two main categories. One is inter-agent protocol, which we see a lot of protocols coming up. Again, some of these are like robot-agent interaction. There are some different application scenarios as well. Some are meant for Internet of Things and other agents. So there are a bunch of these inter-agent protocol, and there are also context-oriented protocol. What are context-oriented protocol? When we make a call to an LLM, whatever we append in the context are some of the resources, right? Like tools are some things. Maybe in RAG, you may search the artifacts and put them in the context, right? So these are all the protocols that let you interact with external systems that are not agents but are useful to form the context, or called context-oriented protocol, right? And the second the other dimension where people divide protocols are general purpose protocol and domain specific protocol. General purpose protocol is something where, in general, if you're developing an agent, you can follow that standard, right? And the protocol is the same, and mostly for communication purposes. And the domain specific protocol is where you sort of create an artifact for your domain. Like, let's say that you are github.com, right? Like you might have heard this robots.txt, right? Github.com would have a robots.txt that will tell you, I will this is a machine readable part of my website, where you can figure out what parts of my web page you can crawl without that you can crawl, right? Similar, so basically they are making things machine readable, right? Whatever is meant for humans are being made machine readable. Similarly, these domain specific ones are machine readable versions of some websites, right? If a website is exposing artifacts, then they can create, let's say, agent.json and then put it in their website in a certain place, in a very commonly accepted space called .well-known/agents.json or something. So these all becomes machine readable, and they're very specific to the domain or the URL that you are exposed to, right? So in today's class, we will cover three protocols: MCP, agent.json, and A2A, mainly because it will give you a flavor of different types of entities, scenarios, and developmental stages, right? So MCP is a well accepted standard, so I'll go into a lot more detail for MCP. Agent to agent protocol is still being tried out. It's good to talk about it, so I'll briefly cover it. And agents.json is still in drafting mode, so I will talk about very briefly, and also tell you like how does the community perceive it going forward, right? What sentiment do they have? So okay, so let's first talk about the model context protocol. So this was introduced by Anthropic in October-November 2024, and by the time it was Jan, almost the entire world was behind MCP, right? It just took like 2 or 3 months for people to figure out how useful this particular protocol was, right? And it also got a community adoption, in the sense that people started to like create search, like I mentioned, for internet, people had the search catalog for all the web pages that are out there, right? So similarly, people found it so useful that they started to build search catalog for MCP servers and clients as well, so that people can use them. So MCP is, like I mentioned earlier, it's a context oriented protocol, where it is a protocol that helps AI agents connect with tools or resources like documents and other prompt based things, right? And so AI applications could be like ChatGPT or any other custom application that you're building. And in almost all tutorials or blogs, you will see that people compare MCP to the USB port, where like, for example, like if you have a USB-C port, then it doesn't matter what electronic device you have, you can easily get connected to it, right? So you don't have to really understand what device this is and things like that. As long as they follow the same communication protocol, the application on both sides, as long, like people who develop like all these other like electronic devices like mouse or keyboard should figure out how to attach them to the USB standard. But once you're done with that, then the communication becomes the same for everybody, right? So MCP is also similar thing. They want to achieve sort of a standardized way of communication between AI applications and external systems. So why do we need standardized way? Like because LangChain defines tools in a very different way. You have to use their annotations. You have to, because when you have an AI application, there should be somewhere where after the LLM says make this tool call, somebody has to execute it, handle the exceptions, get the results, populate them somewhere, and then give the control back to the LLM, right? So that wrapper, it depends on what framework you develop the agentic application in, right? So whatever Claude desktop would probably give you is not something that Lang graph or Lang flow will give you. Like almost no two agentic frameworks are the same. Everything is different. So if you have to, let's say like suddenly your company decides like, okay, let's not use Crew AI. It's costing me so much money. Let's move to Lang graph, right? It's not going to be an easy job, right? You will have to port everything you have done in Crew AI into Lang graph, and you'll have to modify every bit of the code. So, but if you had a standard way of communication, then you might probably want to change only some bits of Lang graph, because whatever interaction that you had with the tools and artifacts could still remain the same, right? So this interoperability becomes a very big problem. And secondly, it takes a lot of time to code, right? So between every framework and every tool, you have to create something from scratch, right? It's not easy to kickstart. Let's say I give you 3 tools. It's not going to be easy to take all the 3 tools and then put it in your code base, right? Although it feels like it should be quite simple, right? So MCP solves that particular problem. Typically, you would create, if there are M applications and N tools, you would create M cross N integrations. But what MCP lets you is that for each tool, you create one MCP server that will act between the tool and the AI applications, right? And for each application, you create an MCP client that can talk to a tool, right? So that MCP client, it doesn't matter, like maybe you have to rewrite the client for a different app or framework, but once you've written it once, then you're good, right? You don't have to write it for all the combinations. So this is the sort of the client server architecture of MCP. Host, here host is the AI application that you're working with. It could be ChatGPT, Claude desktop, or Cursor, Visual Studio Code, any IDE like that you have. And the MCP server is the program that sort of is connected to the resource that you want to leverage. It could be a tool, it could be a corpus of documents, it could be a database, and things like that. And a client is within the host. MCP client will be within the host, and there will be one client per every artifact or per every MCP server that you want to communicate, right? Why do we want this? We want this because session management becomes easy, right? I'll talk in more details about how this architecture helps in overcoming security and privacy and things like that. But this is how the setup looks like. So if a host, so in the usual, let's say if you're developing this through LangGraph, right? Then what you would do is you will see, you will have to by yourself understand. Let's say if this is a API in the internet, let's say this is GitHub's all the APIs that it exposes, right? So you have to manually go by yourself, look into the GitHub's Open API specs, download that specs, right? And then use that in when you build the host. That was a direct path, right? But now you don't have to do that. Everything that GitHub has will be exposed by a server. You just have to talk to the server. It will give you everything that you need, right? So it is not passive anymore. You don't have to pull the documentation and write the code by yourself by understanding everything. That's not that. So that's going to be made easy by the server, which is going to tell you what all it has, and that way it doesn't matter which host you are, whether you're Cursor or Visual Studio Code or Claude Desktop or ChatGPT. for everybody the same server will work, right? Now, so this is, if you see here, we have divided the servers into two blocks. One is a local machine block and one is an internet block. So many a times, let's say if you're building a RAG solution, right? So then you'll have the entire corpus somewhere in your local machine in the server, right? You don't want to keep it in a remote machine. Maybe you want to, but let's say in most cases, you would create a database or an Elasticsearch or things like that and keep it accessible very close to the host. So in those cases, it's still recommended to have an MCP server which will talk to the resource, and then you can instantiate a client which will talk to the server, right, from within the document. And of course, if you have some services, let's say Google Sheets or something, right, and you want your LLM, your AI application to talk to it. So maybe Google by themselves can host a server, MCP server, and then they'll tell you if you want to use Google Sheets API, just talk to the server, right? So now if you see, the onus of making it available is on the service provider, right? So when Anthropic initially brought up this protocol, they made sure all their APIs were exposed through MCPs, but Google or OpenAI did not jump into the train very quickly, right? But by looking at how easy this is to develop AI applications, third-party startups started to build MCP servers for Google applications, right? Because people are willing to pay money to use that MCP server, right? So that's how it started to gain more traction within the community, because it actually reduced the amount of time it will take for you to develop your applications, and we'll see why as we go forward. So based on this, your transport layer could either be STD-IO, right, where you directly talk to the standard input-output within your machine, or it could be over HTTP, and there is something called server sent events, which follows the JSON RPC 2.0 standard at the data layer. So there is already an established protocol which will be used for transport layer. They're not building a new protocol for transport layer. They're only building what is needed on top of that. Okay. So typically this is what will happen in a life cycle, right? You would instantiate your AI application with a simple URL saying, this is my URL for MCP server for which I want you to act as a client, right? And then it would say use STD-IO or HTTP plus SSE, right? That's all the information you have to give to your MCP client, nothing else. Once your AI application starts, the protocol dictates that first the client has to contact the server that is mentioned in its description. It's a very small description, and there is a standard protocol of what JSON object it should send to initialize. And then if the server is responding, it will respond back, and then it creates the initialization step is over. Now it knows the server is actually available, right? Now what it does is that it can request for the list of tools this server has. So here for Slack, it will have all the Slack APIs. For GitHub, it will have all the GitHub APIs. For Google Sheets, it will have all the 20 or 30 APIs that the Google Sheets has. And then it will give you the list of tools. And now the tools is available with you. You can bind it to the LLM with which you're running, right? In your agentic application, you can probably bind one LLM instance with Google Sheets, one LLM instance with the Slack things, or you can probably bind everything that you need into the same thing, or you can create a search index within your memory, and when a user query comes, pick the top 4 things that match and then bind it dynamically. So you can do whatever you want in the AI application layer, right, in the land graph or other application layers. So when a user input comes, then given that it has a list of tools, it will call the tool. So most of the time, so in most frameworks, this was happening in the server side, right? You will have to, once the LLM gives you what tool call to make, you will have to make the HTTP request, and then it's your responsibility to get it back, handle all the errors, exceptions, and things like that. Now it's not your duty anymore. Okay, the client just has to send the request. The server will take care of most of these error handling and all these things, and the onus is on the person who is hosting the MCP server, and then they'll just give you the response back, right? And there are also few other messages in the protocol, but for now this is a simplistic scenario for tool calling, and I'll go through what else you can do slightly later, right? So any questions? No. Okay. So now this fragmentation has made things a lot easier, right? Because now the onus of how a server is to be run is on the person who's exposing the MCP server. So let's say they figured out there is some way people are not using the MCP, the API is right. So then the MCP server can fix it themselves, right? And that will not affect the client at all, right? Because the client just has a list of tools, it will call the tool again and get back what it wants, and they don't have to be bothered with how it gets mapped internally to what API and things like how it gets executed, things like that. And reuse also becomes extremely easy because you just need the MCP server's address and what protocol it should use to call, what transport layer it should use to call, and a few others. Very small snippet. The moment you paste it, then the client gets instantiated and everything happens automatically, right? So MCP servers expose three main primitives. Tools is very obvious, right? Because almost all MCP servers expose tools, right? But in addition to tools, Anthropic also envisioned that people in the future may end up using resources and prompts. Like for example, GitHub may expose a lot of their documentations, right? If you're accessing, let's say for IIT Delhi, it may expose a lot of these policy documents that they have, whatever Senate meeting minutes, like many other things that they may have. And there are also prompts. So this prompts is a very interesting concept, because let's say that the resource that are exposed to you are minutes of meeting in an audio recording or something, right? Or it could be minutes of meeting in a very certain specific format that IIT follows, right? So now if you tell the model, I want to know give me the summary of the minutes that affects me as a master student, or give me the minutes that affects me as a PhD student, right? Then you will have to end up creating your own prompt. The person who's building the AI application has to build their own prompt. But what this protocol says is that if you know there are certain artifacts and people do an action on those artifacts very frequently, then I will create a prompt template for you and make it available to you. So if you have a task at hand, if the user asks the LLM saying, can you, I know that these resources exist in IIT Delhi MCP server, and I want you to summarize the minutes for these meetings. So now the LLM doesn't have to create the prompt necessary from the artifact, because the prompt template it will see what all prompts is available that MCP server exposes. Based on the prompt, it will just reuse it as is, right? And it's not just prompts. There's a lot more things you can do as well, which I'll talk about later, right? So let's look at tools. So all the LLM. So typically in the past, what you would have to do is, like, let's say that you have an API list of tools for flight related tasks, right? Flight booking related tasks. Then you will probably have to take that OpenAI specifications and then convert it into a format that is consumable by a bot, and that JSON would be present hard coded or as a file in your code base, right? And you will end up using it. What this protocol says is that you don't necessarily have to do that. I will give you two methods, right? If you are connected to my MCP server, if you say if you call tool/list, then I will send you all the tools that I have currently. And if you pick one of the tool and then say tool/call, and then you give it the actual tool name and the arguments, then I will execute it and give it back to you, right? So that's what these two methods say. So the actual entity within your AI application that will use these two are typically the LLMs, right? Because you will fit the tools in the context, and the LLM will tell you when to make the tool call and when. So LLM is the main consumer for these tools within the protocol, and so this could have safety issues, because let's say you're writing back to GitHub, right? If there is an incorrect write that happens, then it may screw up things, right? So the protocol allows you to have approval from the human, so you can specify these things. When you call these tools, then make sure that you get approval from the end user before you execute things, right? And there are a few other things that the protocol gives you out of the box so that you don't have to go through the effort of coding it within your logic, right? So this makes development of AI agents much more easier, right? So you just have to specify one parameter here and there, and then everything will get materialized very quickly, right? Now, so resources are mostly like documents. Let's say if you have a calendar app, MCP server, maybe all your calendar entries, the database of your calendar entries could be available as a read-only resource, right? It may also have all the meetings that you've had in the past, like so that like if there is any information that I have to derive out of that resources, I can call the resource, search through it, and then derive some insights and then use it as input to my prompt, something like a working memory, right? So MCP allows an MCP server to have a lot of artifacts, and then they can explain what those resources are in the description, and LLMs can use it to augment the context when needed, right? So most of these are going to be only read-only operations, right? Nothing more, and all of them are only read-only operations. And because since they are only read-only, then the security is not that big a concern. Although you might need access control, right? Because let's say that these are mark sheets, in the resources are mark sheets, right? Then it's probably not a good idea to give all students access to everybody's mark sheets, right? So you might have to do still some control there. There may be some security risks. Same thing with banking. You don't want everybody to see everybody else's bank accounts, right? So things like that. But still, it's slightly less of an issue than tools. And typically, it's only the AI application that will have control to the resources, not the model, right? The model will get it through if the AI application decides to put it in the prompt, but otherwise it won't have access to the resources. So some of the methods that are available are, you can just ask it to list all the resources. So it would say something like, I am a calendar MCP server, and there is a folder called events, and there's a resource for 2024. So this will return this resource. If you call this resource, it will return you all the calendar entries in 2024. So these are the resource list, and then if you use this particular key, and then you say I want to read this particular resource, then it will give you back the contents, right? Now they also introduce something called templated list, because many times you have a huge chunk of resources, and it's practically not a good idea to expose all the things that you have, right? So for example, your mail, right? Even though you can give them access to all mails, but what is the point? You need a better way of navigating that particular resource, right? So they have these templates where, for example, they say that if you want a list of activities that are available in a certain city about a certain type, then this is the general template that we follow. If you provide the name of the city, let's say Barcelona, and category as museums, then it will give you a list of museums, right? And the protocol allows autocomplete for these. So as a AI application starts to write something or partially completes and sends it to the MCP server, let's say it puts JFK, maybe it's searching for some airport, JFK, then it will hit the MCP server, get completions that will fit this particular partial completion, right? And it's up to the AI application to sort of use it in a way that can be rendered to the user as well, right? You can, because it allows streaming, you can easily make sure that things like these can be made available to the user. As the user is typing some fields, you can make sure that you create a drop down so that they can select from there, right? So it's up to you how you design it. So the protocol clearly defines what API you should call when you need those completions and things like that, right? And finally, prompts, like I said, they are basically more like, so how many of you have used Slack here? Or how many of how many of you have used Visual Studio Code? Awesome. So in Visual Studio Code, you can, there's a terminal like thing where you can start with a slash and it starts giving you all the shortcuts to the commands that you have, right? So they thought of a similar technique for prompts as well. As a user, let's say that you have a task at hand, right? So one thing you can do is just write the task completely and then let the model figure out how it should solve it. The other way they say is, if you enter a slash in your console, then it will give access to all the prompts that are exposed through MCP servers, right? So you will know what are the very commonly used tasks, right? So then what they say is that, let's say you want to do code review, right? So the moment you say slash code, this code review will come and it will say, give me the code and give me the language that you're using. So you can directly fill that, and this will internally make sure that it will create the prompt of what is needed. It will figure out how to create the LLM prompt and then send it to the user, right? So this is more like a feedback that people typically give when they build agentic solutions, that it doesn't work for very common use cases. Like for naive and novice users, they would want to enter the whole thing, right? But let's say that you've started to interact with the agent and then you become very familiar. You know exactly what you want to do, but still writing the entire thing is painful, right? You don't want to do that, right? So this is one way that MCP provides you, so that when you build your application, you don't necessarily have to make the user write everything from scratch, right? Let's say you want to do a travel planning app, right? The moment you put slash plan, then it'll tell you just fill start, end date, where you want to go, and some other fields, right? And then it'll figure out how it has to create the prompt and then do all the work for you, right? So that this will make it a lot easier, because you will not miss out the necessary fields. You will give everything and you don't have to worry about how to express it. So it solves a lot of these problems. And as you see here, this is how it will internally be implemented. Like if you write slash code underscore review, then it will just say give me code and language, and everything else is masked from you, right? Now let's say that the MCP server who is exposing the travel agent thingy, right, figured out there's a better prompt to do it. Then the people who are actually building it know what's the right prompt, right? So they can easily update this without the client having to know what really happened, right? Otherwise, that prompt is a very valuable resource that may not get transferred in the right way, right? But now because of MCP, it becomes a lot easier for people to reuse things that are well explored and have been well studied. Now, so let's see like some advantages of MCP. So I talked about that MCP also helps in privacy and security, right? So the way it does is that, so let's take this particular config, right? So this particular config is where you want to expose GitHub tools to your AI application, right? So what you're going to say is that there is this particular, so this is going to be, this MCP server is going to run in my local machine. So it uses the STD-IO transport. And in the local machine, if they run npx -y and this command, then I should be able to access the server, right? And if the server is not running, this command will make sure the server runs, right? And this part is separated from this part, which is the GitHub tokens or any secrets or credentials that you are sending. You are not sending it through the LLM, right? Typically, what would you do? If a GitHub API tool is there, it will take the access token as one of the inputs, and then you will give the other inputs, right? Now, if you let the LLM by itself predict this tool call, then at some point in time, the LLM is going to ask for your access token or credentials, or you will have to provide this as a part of the input to the LLM. Now, if you provide that, then it's going to go to the cloud. You're going to lose it's not safe anymore, right? So that is the issue with many real-world applications that use LLMs that are hosted in the cloud, right? So this is the good part about MCP. The MCP client will access your local environment and then take the authentication, and when it initializes the first handshake between the server, it will use this token and it will keep the secret with itself. It's never going to give the secret to the LLM, right? So this decoupling of tool invocation from LLM response. So ideally, whatever LLM response comes, you directly execute it somewhere, right? But now you've decoupled it. LLM gives a subset of the parameters that are necessary, and the MCP client keeps some subset of the parameters that is secure that has personal information that you don't want to. So you can do a lot more things with MCP because of this decoupling, and that helps in a lot of these privacy related issues and security related issues. Right? And the second biggest advantage is that any server side modifications is never going to affect your application. So let me rephrase it this way. Let's say GitHub updated their APIs. That's very unlikely to happen because GitHub is so matured. But let's say you are working with you're the booking.com agent, right? So then you will have access to all the flight airline providers, right? And if you have, let's say, 1,000 airline providers, so somebody is going to change their APIs now and then, right? Now, when somebody changes their API, how will you get to know? Because the way you've developed your application is you went to their website, downloaded their open API specs, put it on your machine, and when your AI application starts, it's going to read that, and then it's going to keep that as a set of tools. Now, when will you get to know that you are actually doing the wrong tool call? Maybe if it is backward compatible, you are good. If it is not, if it throws an error, you are saved, because continuously the model is throwing an error when I call this particular API, that will let you know. But what if it succeeds and it's incorrect? Right? Maybe they had an optional field before, maybe they had a mandatory field before, and then they made it optional, and things started to change because of that, right? So all these issues might happen, and if it's a breaking change, then sometimes maybe you have not handled the exceptions properly, or probably if the model doesn't give back, your entire workflow breaks, then of course you will have downtime, right? You will have to, because you will have to restart, you have to download, figure out which went wrong, go to their website, download the new API specs, put it in your code base, restart your thing, and maybe if it accepts as is, it's okay. Otherwise, you have to change your code sometimes as well. So this is going to be extremely painful, right? But MCP approach solves this problem, right? Because the protocol says that if you register for notification of changes, then the MCP server, when it does the initial handshake, the MCP client can tell if there is some change in your artifact, in your resources, if there is some change in your prompt, or if there is some change in your tools, let me know, right? It has to say that. Now, if there is any change, then the MCP server will know that something changed, right? So then it will tell the client, then the client will terminate the connection, restart the connection, and get everything that's needed again. So this way, there is no downtime at all. So again, this also saves a lot of effort and developer time, right? So all these things put together of how they divide and conquer the problem, like server will be done by somebody else, and you can, and some startups started to create MCP servers for a lot of these common applications for which they don't necessarily have to get licensed to host them. And then they started to sell that MCP servers for other people to use. People found it a lot more convenient to buy MCP servers rather than coding it themselves for every application that they have, right? So this ecosystem started to develop very quickly, and that is one good reason why this is the most accepted protocol yet. And also Anthropic put in a lot of effort to make sure that they covered a lot of these very popular, very common issues that people face, and then they made sure that they took into account everything. Okay, so whatever I talked about MCP is at a very high level, but it's a lot more complicated, and there is a lot more room for development within that, right? So the more deeper you go, I think once you start implementing agents, once you because typically when you implement agents, you will start with LangGraph most likely, right? And then you develop something that's usable, and then when you start to build more and more agents, you will realize what is the downfall of LangGraph. Maybe you want to use a different framework for it. Then after you develop multiple agents and you realize, oh, I want both these agents to work together. Now I have to create a third agent, which you will have to make sure that this agent and this agent will be able to talk, that agent, to create a unified interface. Things become very complex very easily, right? And so protocol like MCP will help you overcome most of these issues, if not all, right? So next, we'll talk about agent to agent protocol. Again, this is a protocol that was developed by Google very recently, and some partners of Google have adopted this, but it's not sort of like picked up at a pace where everybody started to adopt this, right? So there are three in MCP. there were 4 actors. There was a user, there was a host, there was a MCP client and an MCP server, right? Here there are just going to be 3 actors. There's going to be a user, of course, the person who's going to use the agent at hand, and there's going to be a agent to agent client or the client agent, which is the agent to which the user is going to interact, right? Because if it is a multi-agent system, it's not like the user is going to interact with every agent, right? The user is going to face only one agent, and the A2A protocol will let that agent communicate with other agents that it knows, right? And of course, the remote agent or the A2A server is all the other agents that are out there which the client agent knows about, right? For example, there could be a travel planner agent, which is a client agent which the user is talking to, and this travel planner agent knows that there is a flight booking agent, it knows that there is a hotel reservation agent that it can access, it knows a currency conversion agent and also local tours agent, right? Now, it need not necessarily be like this, where one agent is like the client is in a star network where it's in the middle and it has access to every other agent. It could also be more like a mesh or a different topology as well, where the client agent may call agent A in turn can call agent B can in turn call agent C, and they can go back and come. So it can be in, like, the protocol allows you to have any type of these architectures. The only requirement is that you should be aware of what exists out there, or the other agents should make themselves discoverable to you, right? So let's see how this happens. So to make this happen, every agent is given an ID, or like just like in Hugging Face, how every model has a model card, and by reading the model card, you know what is the name of the model, what can it help you with, what type of prompts you should use when you use the model, how big is the model, and what are its performance in various data sets and things like that, right? So similar to a model card in Hugging Face, you will also have an agent card for each of the agent in this protocol, right? And they have certain attributes and metadata that they associate with that the agent has to fill up, right? And the main reason for this agent card is discovery, right? And discovery, and after it discovers the agent, it should also be in a position to figure out whether it's going to be useful for this particular subtask or not, right? So this is the main use of the agent card. And agent card also gives you some information about how to communicate, what type of exchanges that you have to do to establish a bond, and then it will accept to do your task. So all these information will be present in the agent card. And one terminology that they use is task, where it is a subtask that you want to accomplish. The user gave you a bigger task, and there is a subtask that you want to accomplish by using a different agent. So that would be a subtask. And to accomplish that subtask, you'll have to send a lot of messages between the two agents, right? For example, if you are a travel planner, and then it says that could you plan my travel to let's say Barcelona for summer, right? Or for February. So then you probably first need to know what is the weather in February, so that you can design activities accordingly, or book places accordingly, or book flights accordingly. So then you might say that what is the weather in Barcelona in Feb, right? And then probably the weather agent can come back and say, give me some date range, so that I can tell you. Maybe you just want the entire Feb, or you want some other dates. So things like that. So they can, or it can assume that entire Feb and give back all the details, and it probably missed rain prediction. So then it can give me rain prediction as well, along with the temperature. So then things like that would be happening with messages. And along with messages, sometimes you might want to, the other agent will, or either the client or the server might want to send some artifacts like images or files. Let's say like one agent is willing to summarize documents, the other agent has a document, so it has to give the document, and after summary, the summary will be passed and as a file and things like that. And artifact is like for an entire task, what is that final thing that you got out that is meaningful? Okay? These are the terms that they use in the agent to agent protocol. I'm not going into much detail of agent to agent protocol, because firstly, whatever I said now is mostly how it is implemented, right? And the details are not as interesting as it as it was for MCP, because MCP was slightly more complicated, so going into details made sense. But agent to agent, like sort of at an abstract level, is what is, right? So let's, given that we've seen one inter-agent protocol and one context protocol, so both are meant for two different tasks. So you can of course combine both. You can use both protocols in your AI application, right? So let's say that you've decided that I'm not going to use A2A, I'm just going to use MCP in your application, right? So then let's say that there is a flight server which has a flight server, MCP flight server, there's an MCP hotel server and MCP weather server, right? So then all the logic, so it exposes all the functions that it has, MCP server. So once you do the tool/list, all these MCP servers will give you all the tools. Now when the user says, I want to plan a 5-day trip from Beijing to New York, then all the intelligence has to lie within one travel agent that will figure out how to use flight server, how to use hotel server, how to mix and match, how to use weather to narrow down which one should I call first, which one should I call second. So it has to make a very, very fine-grained decision in how to get things done, right? On the other hand, let's say if flight server was not an MCP, but it was an agent by itself, right, which is a flight agent, and the hotel server was an agent by itself, which has access to the hotel server MCP by itself, but if you give it a date and some conditions, it will book all those things, take care of payment and all those things, it will do it by itself, and you don't have to worry about it. And let's say that there is also an activity agent, which you don't have to think about the weather. The activity agent by itself will call the weather agent and get the necessary information it needs and just gives you activities, right? So typically when you design, in a long run, when things become a lot more collaborative, A to A is very useful, right? Because the travel agent does not have to make fine-grained decisions and figure out how to stitch all of them together. You can just at a very broad level think, okay, I know I have these 3 agents, I'll just distribute this work first, and once the agent comes back saying I booked your flight ticket, then I'll send it to the hotel because I know the flight timings. Now I'll send it to the hotel, and then once the hotel comes back, then I will send it to the activity agent, and then it'll get back. It doesn't have to worry about weather at all, right? So similarly, and now the flight agent can be reused in a different setup as well, right? So whatever advantages you had from MCP are also the advantages you will get in A2A protocol, right? And now the issue is, how do you discover, right? For MCP, there are websites where you can go search for something and it'll give you all the MCP servers that are available. A2A is not at that stage yet, right? So people have not adopted it in such a way where there's a marketplace where you will go and search the catalog and figure out what all agents are available and figure out whether do I have the credentials to use it, whether I have enough trust in using the server and things like that, right? And so far what they have done is that you need to exactly know the agent and then hard code it in your right? So it sort of is reflecting what issues for which MCP was developed, similar issues A2A is facing, right? Okay, so let's move on to agents.json. So this work was started around in the beginning of the year, and they left it hanging around April, and then they went on to do something else because it was not getting picked up, and MCP became too popular. So I'll tell you what this protocol is meant for. So typically, let's say you have an MCP server for Gmail, or you have an MCP server for GitHub. There are going to be like insane number of functions, right? Like sometimes you might have 50 to 200 functions, right? And all these functions were primarily designed for developers, right? In the sense that they want to expose software as a service for GitHub, and then all the data lies in a backend somewhere. And so they would have created APIs for the backend so that your UI would be able to work the way it works now, right? They were not meant for people outside GitHub to leverage it. But as people started to develop plugin for VS Code or plugin for Eclipse, then they slowly started to make the documentation good. so that people who develop these plugins can understand what these APIs do and do it, right? So when you're developing an API for internal use, then you will have a certain level of details in it. When you're exposing it and you know there's a community that's going to consume your APIs, then there is going to be a different level of additional information you'll provide. But most of the existing tools and tool definitions don't assume that they are going to be used by LLMs, right? And why does this create a problem? Because typically users say what they want. They don't know what APIs exist. So then it becomes the headache of the LLM to figure out how I should use the existing APIs, stitch them together, what variable should go in which other variable, what output should go to which input, what I should ask from the user, and then figure out how to accomplish the task. Sometimes it's not straightforward to understand that for achieving this task, I have to call these sequence of APIs. And one example they gave is that, let's say that the user says, I want to reply to latest email from Bob, and says what they want to reply, right? So now it's not a single API call. First, you need to figure out the latest messages from Bob, and then you'll have to figure out what is the latest message in that chain from Bob, and then you'll have to reply to that message. And the reply to API takes the base 64 RFC 822 content as input to reply back, right? So now you have to figure out that key. Where did you get the key from? And that detail is not very clear in the documentation. You know some key has to go there, right? Now you have to search for the message Bob did and figure out how to get the key for it, and then use the key and then reply, right? So now if you have such a situation, what people do is, when they write system instructions for the agent, they'll provide all these details. When the user asks that they want to reply to somebody, then make sure first you get the list of messages from the sender, and then figure out the thread ID from there, and then get the latest post in the thread, get that base 64 ID, and then use that ID as this with this function to reply back, right? And this doesn't happen. Even if you say the LLM to make all these things, it will not do it, because it won't know which is that. If there are 7 different keys in the response object, it won't know which key to pick. So then again, after that, once you see it's not working, again you go back, see why it's not working, see the output and figure out, and then write it down in the instruction, right? Sometimes it may work, and sometimes you change the input slightly, saying I want to reply for the latest message from my boss or something, then everything will break loose, because now it's not able to figure out the contact and things like that, right? So this has always been a big issue, and currently people struggle to write system instructions. Sometimes people rewrite the API description, because people download the open API specs and then put it in the local machine, right? So if that API is not well described, LLM will not be able to pick it, so they will modify their description so that LLM will be able to pick it, right? And sometimes what happens, parameters are not well described. Maybe they have just written the name of the parameter and description is left empty. So model is not able to figure out, right? And people sometimes name variables also weirdly. It is not expressive. So this always becomes a big problem. So what this particular protocol tries to achieve is that I will have something called flows and links. Flows is that if somebody asks me questions like these, then I'll have to follow this flow. Like reply to a contact will be the name of the new flow that you're building. And then in that you will say, first you call search threads with these arguments, and then list email threads with this argument. The output of the response object from here and this particular element in the response object will go as input to the second input. So those are the links. So you define the entire flow, you define the link, and you create a new higher abstraction of an API, which is now readable by the LLM, right? Because now if it says reply to a contact, latest email from contact, then it will be able to use this in that particular order and then use it, right? So this is what they came up with, and this was actually a real problem a lot of people faced, but people started to come up with their own solutions to fix this. Because if you anyway have to create an agent.json wherein you create an abstraction by yourself and writing it down, then I would rather change the API description, or I will create something in Python and put it in LangGraph, right? So people came up with a lot of different solutions, and this didn't get picked up as much as it should, because other frameworks started to circumvent that problem in a different way. and they made it easier for people, right? So some of these protocols that are coming up now will eventually face this, right? Because the problem exists, but the solution protocol may not be the right solution for it, right? And this is the place where even the prompts in MCP can help, because you can define a workflow there. Currently, you have to define it in a custom manner by using the metadata field, which allows custom fields. But I'm hoping that at some point in time in the future, even MCP could directly start support things like this, right? Because now if Google creates these abstractions, then it can be used by everybody else, right? Because if you create agents.json, it is more domain specific. Like you provide it for your particular application. It's not going to be like general purpose, right? So this is one reason why agents.json didn't pick up, because their vision was not as clear as it should have been, right? Okay, so to summarize, we saw 3 protocols. One was MCP, which was context-oriented general purpose, and it is well accepted standard everybody uses. And then we saw A2A, which is currently first draft is done and people are testing it. It looks reasonable. Looks like there are a lot of agent to agent general purpose protocols. Like, see, there are already 3 here, right? So it's very likely that the A2A protocol will win the race and the others will die down soon, right? But still there may be a lot more changes to A2A as and when we saw one problem, which is discovery is slightly an issue now. So let's see how the community will work on that. And lastly, we saw a protocol that was still in drafting stage, but it was ditched because the issue that it faced was sort of solved by somebody else, right? So if you see here, there are a lot of drafting, right? There are some landing where it is in the same domain as something that's getting more popularity. So most of these will die out and only a couple of them would survive. But still everything is work in progress. And similarly, things may get reused within the protocol as well. Maybe A2A and MCP will join hands and create a master protocol that solves everything, right? So still it's a very evolving field. MCP seems like a clear success at the moment, but others are still sort of work in progress. All right. That's all we had for protocols. Thank you.